Hello student, now we will see the next concept, types of the data structure in detail. Already we have seen one point, classification of data structure in video 2. Now this point we will see in more detail in this video. So the major types of the data structures are primitive non-primitive, linear non-linear, static dynamic, persistent and ephemeral data structures. So already we have seen the primitive and the non-primitive data structure. So the primitive data structures are nothing but what the basic data types that are provided by the programming language such as integer, float, double, etc. These are the primitive data type languages, primitive data structures, and they have the machine level support. Therefore, they have the predefined way of storing the data by the system or the machine, and they are going to perform or they have the fixed predefined operations. For example, suppose we have the double data structure. So in the double data structure, the representation of the value of the double is going to be fixed by the machine, as well as the operation which are going to perform on that double is also going to be what the fix. For example, we cannot do the modulo on the double, but we can do the addition, subtraction, multiplication, division. So these are all the predefined operations that we can perform on the data structures. The next is non-primitive data structure. The non-primitive data structure are derived from the primitive data structure, and they are used to store group of the values. So for example, the structure, arrays, linked list, these all are what the example of the non-primitive data structures. So the next category is linear and the non-linear data structure. So the linear data structure where data is organized sequentially or linearly. So for example, array, linked list, these all are the example of what the linear data structure. Non-linear data structure means the data structure where data is not organized in the sequentially. So maybe in the form of trees, like data is organized in the hierarchical fashion. So the level of the data is in the linear, it is a level 1, but the non-linear, it is a multi-level. The data is organized in the multi-level. So if we can differentiate the data structure in this both in many ways. So for example, the data organization is going to be sequential, that is the first one. The data is going to be accessed in the single run in the linear one, but in the non-linear one it is not possible to access the data in the single run. So the next is memory efficiency of the non-linear is going to be more. So for example, like trees, graph, where the networks are going to be represented in the form of what the graph. So these are the example of the non-linear data structures. So that is also one of the linear data structures are simple, while the non-linear data structure are complex. So in this way you can categorize the data structure in the linear and the non-linear type. The next is static and dynamic data structure. Static means the size of the data structure is going to be fixed. So you can modify the content of that data structure, but we cannot change the memory allocated to that data structure. So for example, array. So in the array, what we can do is the memory, suppose I want to access the second element, I can access it or I can modify this, but I cannot change the memory allocated to that array. So if I have said that it is an integer a of 10, so the memory for the 10 integer atoms is allocated. I cannot change the memory allocation to the array. So it falls into the static data structure type. So the next is dynamic data structure, where the size of the data structure is not fixed and can be modified during the operations going to perform. For example, linked list. If I want to do the delete one, so the size of that particular linked list is going to be what the small. If I want to insert, the size is going to be what the going to change at the runtime. So that is what the dynamic data structure. So the next type is persistent and the ephemeral data structure. Persistent data structure is what the data structure which always preserve the previous version when it is modified. So for example, if I have some timeline and suppose that if if I am at this particular time, so I can go to the previous versions and I can ask the questions, I can access the thing. So what is the persistent data structure is which always going to preserve the previous versions. So if suppose if I am at this current version, if I want to update this, so I will go to the next version over here, but at the same time I can access my previous version. So the persistent data structures are at the different levels. So for example, the two levels we will discuss. The first level is what the partial persistent data structure and fully persistent data structure. What is a partial persistent data structure is all version we can access but we cannot change its value. But fully persistence means what? I can access the previous one or I can change its value also. So this data structure are effectively immutable and their operation do not update the structure in place. Instead, they always yield to a new updated structure. So programmatically, I will give one example of the data structure called as a string in the Java. So in the string in the Java, if I will create one string variable a in the Java, and if I will say a is equal to PICT, and after some time I have changed the value of a so to the SCTR. So what is going to happen in the memory? This PICT is not going to be changed. Okay. Instead of that, the new memory allocation is going to be there where the SCTR is going to be stored and my A is going to point to that new memory. But it is not a persistent because the older version we cannot access. So, but what I want to say that this is one of the data structure which is what the immutable, but this is not a persistent data structure. So the programming language like what the meta language or the some functional programming language like Haskell, they supports the persistent data structure. They never change the original data structure. Instead of that, whenever we will do some kind of the operation, they will always create a new data structure and which is not going to modify the original one. So what is going to happen? We can access the previous versions as well as the updated version. So for example, we have the to list and we want to do the concatenation by using this particular statement. So in the Haskell, so what is going to be happen? So initially in the memory, these two lists are arranged like this after one by one, and whenever I will concatenate, what the your resultant one will what it will create a new list copied the what the first list, and the pointer of this is going to be point to the second list. In this way, you can access the to list as well as the updated list. Next data structure type is what the ephemeral data structure. So the data structure which are not persistent are the ephemeral data structures. Modification destroys the version which we have modified. Changes are destructive, so only one version is available. So you can take any kind of the data structure, maybe array, maybe your computer RAM. These all are the example of this particular kind of data structure. So if we have modified that one, we cannot access the previous version because what is going to happen? The modification is going to destroy its value. So we cannot access what its previous value. So we can only access the latest value or the only one version. So these are the basically the detailed classification of the data structure. If you have any query related to this, please write at me psvidep@pict.edu. Thank you, students.